Okay, everybody, we are now going to resume Chapter 1, Lesson 1. Again, this is your instructor, Brianne Pernick. We left off by finishing talking about how to convert a situation into a real number. We are now going to start talking about how every number has an opposite, which is also called the number's additive inverse. You need to make sure that you understand that an opposite and an additive inverse are exactly the same thing. Now, we did talk about how in the whole number group, we started with 0, 1, 2, 3, 4, etc. When we moved into the group of the integers, we started to include their opposites, -4, -3, -1, or excuse me, -2, -1, 0. I promise I can count. 1, 2, 3, 4, etc. When we include those opposites, which are also called the additive inverse, that becomes very important to how we are going to learn to solve problems a little bit later on. So finding the additive inverse, or being able to find the additive inverse, is very important for you to be able to do. So let's just refresh our memories on exactly what an opposite or additive inverse is for a number. If we have the number 3, its opposite is -3. If you have the number -5, its opposite is +5. It's always going to be exactly the same number with the opposite sign. So right now, I'd like you to take a minute, pause the recording, and pencil in the opposites or additive inverses for A, B, and C. Okay, by now you should have been able to fill in those opposites. Letter A, the opposite for -7 is +7. For letter B, the additive inverse for 1/4 is -1/4. And lastly, for letter C, the additive inverse or opposite for 3.28 is -3.28. We're now going to move on and talk about what absolute value is. The definition for absolute value is a number's distance from 0 on a number line. If you picture that number line that I drew for you up here a little bit ago on page 1, and think about a distance. Let's think about the number 3. Okay, let's say that we started on 0 and walked to 3. We would have taken 1, 2, 3 steps to get from 0 to 3. If we did that same exact thing for -3, how many steps would we have had to have taken to get from 0 to -3? Well, 1 step, 2 steps, 3 steps. Okay? Absolute value is a distance from 0. If you want to think of it in terms of steps away from 0, it was 3 units to get from 0 to 3. It was also 3 units or 3 steps to get from 0 to -3. You need to remember that distances are always positive. Therefore, absolute value will always be positive. Another way that you can think about this is think about driving a car. If someone asks you, how far did you drive? I drove 100 yards. If someone says to you, well, how far did you have to back up? I had to back up 100 yards. We don't ever say, that I drove negative 100 yards, even though backing up 100 yards and driving negative 100 yards is essentially the same thing. It's just using the word backing up makes so much more sense to us than saying that you drove negative 100 yards. That comes back to being able to use a real number to represent a situation, and vice versa, using a situation to represent a real number. So what we need to remember here is that distances are always positive. So when you are asked to find an absolute value, you need to remember that you're being asked to find the distance from 0 on that number line. So the absolute value for negative 4.62 is simply 4.62. It's 4.62 units away from 0. The absolute value of 3/7 is 3/7. It is 3/7 of a unit away from 0. And then lastly, we have the absolute value, we have the negative square root of 11. Now, that one is not asking us to find an absolute value. Perhaps it was a typo. Let's just find the negative absolute value because we're not ready to do square roots yet. I think that was a typo on there. My apologies. So we're going to find the negative square root, and that's positive 11 in there, guys, of 11. So what you would first do is evaluate the absolute value, and then you would say to yourself, absolute values should always be positive. So the absolute value of 11 is 11. Once you evaluate that absolute value, since it's asking for technically what this is saying is find the opposite of the absolute value of 11. So you're going to bring down that sign from here to here because it is telling us find the opposite of your answer. Since we determined that the absolute value of 11 was 11, we're going to say that the opposite of that is negative 11. So that's just a little tricky right there. Okay, the next topic that we're going to learn to work with here is adding numbers that have the same sign. So what I want you to think about here is combining things. When you are adding two numbers that have the same sign, you have two rules here. First, you're going to add the numbers and keep the sign. Those are your only two steps if they have the same sign. So 13 plus 41 is 54. Letter B, we have a negative 11 and we're adding that to a negative 5. So we have two numbers with the same sign. So we're going to add our numbers and keep the sign. 11 plus 5 is 16. We keep the sign, so it is negative 16. Please pause the recording, take a second, and solve C and D. Okay, by now you should have had an opportunity to solve C and D. Let's go over the work here. In order to combine the fractions here, the first thing that we need to do is find a common denominator. So we are going to convert our fractions to a denominator of 15. Now, nicely, the second fraction is already a fraction of 15, so we're just going to leave that as negative 2/15. And for the first fraction, we had to multiply by a 3 to go from 5 to 15. So 5 times 3 gave us 15. 4 times 3 is going to give us 12. Now, the steps say add the numbers, keep the sign. So to add the fractions, 12 15ths plus 2 15ths gives us 4 15ths. And we keep the sign, which was negative. So we should have negative 14 15ths. And now letter D, all three of our numbers are negative. So we have negative 7 plus negative 2 and negative 5. So we are just simply going to add those. 7 plus 2 is 9. 9 plus 5 is 14. And we keep our sign. Now, the tricky part here comes when your signs are different. If your signs are different, you are going to first subtract the numbers. And second, keep the sign of your number that had the larger absolute value. So with letter A, I'm going to notice that I have a negative 3 and a positive 5. You do read the sign that is directly in front of the number as its sign. Even though when we put them together as an expression, we read it as a plus, that is a positive 5. So we're going to subtract. 5 minus 3 is 2. Now, which number had the bigger absolute value, 3 or 5? 5 is bigger, so our answer will be positive. Now, for letter B, we're going to subtract those numbers because 8 is positive and 7 is negative, so 8 minus 7 makes 1. 8 is bigger than 7, therefore our answer will be positive. And now it is time for our last topic here. We are going to review the addition properties. It's important for you to learn these properties because addition properties can truly help you solve problems faster. The first problem that we are going to talk about is the fact that addition is commutative. So we're going to talk about the commutative property of addition. What this property says is that we can add in any order that we want to, and we will always get the same result. So an example of that is 3 plus 6 is 9. 6 plus 3 is still 9. You can add in whatever order you want to, and your answer will always be the same. What we're getting at here is that you can rearrange your terms so that all of your negatives are together and all of your positives are together, because that will help you to do the addition. Now, the second property is the property of 0. The addition property of 0 states that anytime you add 0 to a number, your result will stay the same as your number. 0 plus 5 is 5. Negative 8 plus 0 is still negative 8. Not going to change. The last property that we're going to review is the associative property of addition. Addition is associative, and what that means is that we can group numbers together and still get the same result, and we can regroup them as necessary and still get the same result. So on the left-hand side, we started with 3 plus 5 plus 7 in a group. 5 plus 7 makes 12. 3 plus 12, sorry about that there, makes 15. But on the other side, they regrouped their numbers because they felt that 3 plus 5 was a little bit easier to add. 3 plus 5 is 8. 8 plus 7 is still 15. So addition is commutative. I'd like you to go ahead and look at these two examples here and determine which properties you think would be better to use. Think about why. Go ahead and pause your recording. The first problem, you should use the commutative property. You can put your two positives together and add and have 7/17 plus negative 8/17. The last property here, I would have also used commutative because you can rearrange those terms and add. This ends our lesson.